Hello students, today we are going to perform a next experiment, that is to configure and compare various network topologies using Cisco packet tracer. So we will be having a comparison of bus, star, mesh, ring, dual ring, tree and hybrid topology. First let us see what is a bus topology. When a number of devices they are connected one after the other to form a bus, that is what is a bus topology. The topology is basically the fashion in which the different devices they are connected. Uh, okay, we can see over here there is a backbone line that is having a switch, and different pieces those are connected to that particular switch. Basically, uh, there is only a one backbone line, and the PCs, the devices, they are connected to the backbone line by the drop lines. Uh, the different points those are associated with the bus topology is that the total number of links those are associated over here. That is a single backbone line we have seen, and the n number of lines, drop lines to connect the number of devices. Suppose we have n number of devices to connect to the backbone line, n number of drop lines will be required, right? Next is a privacy. We can see over here in a diagram that whenever data flow from these device to these device, it goes through all the devices. That is hereby all the devices. So there is no privacy. The number of IO lines required are one IO line that is required to connect the device. Installation and reconnection, that is difficult because of the lines those are required over here, and the fault identification and isolation as well. If there is a failure in one of the device, there will be a difficult procedure for identification and isolation. Application of the bus topology that is not used in the large networks, because as you go on adding up the devices, the signal quality will get degraded, and that's the reason we do not use it in a large networks. The line configuration is a multi-point configuration, and the cost is the least expensive, because what additional cost you are required apart from the devices and the backbone line is the drop lines to connect the pieces to the backbone line. So that is what is the cost that is considered to be least expensive compared to the other topology that we are going to learn then after. Okay. Next topology we can see over here is a star topology. There is a single central point, and to which there are number of devices connected, and that forms a star. That's the reason it is called as a star connection. Different points those are associated with the star connection. Total number of links required are to connect the n number of devices to this particular central hub. What we have are the number of lines will be required. Then is a privacy. There is a no privacy. In this case, the number of IO devices will be one. Installation and reconnection, you can add up as much of number of devices those are required. So that is easy one. Fault identification as well, it is easy. Application, basically star topology is used in the LANs and the high speed LANs. Line configuration, it is point to point configuration, right? And the cost is considered to be less expensive. Then is a next topology, that is a mesh topology. In a mesh topology, every device that is connected to every other device. So we can see over here are the number of 5 devices. Those are connected via switches. Okay, and every device that is connected to every other device to form a mesh. So what are the different advantages and disadvantages associated with the mesh? The first point that is associated is the total number of links. So to connect a particular device to the network, because it is connected to every other node, the number of links required will be n into n minus 1 by 2. Okay. And then the privacy, yes, because there is a dedicated connection between each and every two devices. That's the reason the privacy is maintained. Then the IO lines required are IO ports required here are n minus 1. Installation and reconnection, yes, of course, because every device is connected to every other device. Installation and connection is considered to be difficult one over here. Fault identification will be and isolation if there is a problem in any of the device. The isolation of that particular device will be done easily. Application, basically regional telephone offices, they belong to the mesh topology. Line configuration, that is a point-to-point configuration, and because the n into n minus 1 by 2 number of links are required to connect the n devices, and the n minus 1 IO ports are required, this topology is considered to be a expensive one. Then is a ring topology. We can see over here is the ring topology. So here, what you have, the different devices, they are connected to each other to form a ring kind of fashion. Okay, so how data flows, that if you want to send the data from one this device to this device, that flows via these link and that reaches over here. So that is what is about the ring topology, the different advantages and disadvantages associated with it. The total number of links are n. Privacy, because that has to pass through the other devices as well. The data has to pass through the other devices as well. The privacy is not maintained. IO links for each device is one. Installation and reconnection, as well as fault identification and isolation, that is easy for the ring topology. Applications are IBM's token ring is based on the ring topology. Line configuration is a multi-point configuration and the cost is a moderate one. Okay, so those that was the just revision of the things that we have already discussed in a class about the different topologies. Now let us configure a network using a Cisco packet tracer. So now I have already made some of the topologies over here. We will go through each and every topology. Let us start with the bus topology. So what we have are the different switches. Those are connected to each other. Okay, and that is why with the help of that automatic connection, I will show you over here that we have a switch. Okay, switch PT I have used over here, and then after we will make the connection between the switches. Okay, two, then three, and then yes, we're done. And then after we will connect the different end devices. One, then it's a two, then three, and four. Okay, and then after we will make the connection. One, then two, three, and for these as well. Okay, then we will configure the PCs. So I have defined address 10.0.0.1. So I'll select a PC. We'll go to the desktop IP config. And what is that? 10.0.0.1. Right. Is we are done with that. And similarly, we will be configuring all other devices. Okay. The IP address should not be duplicated one. All the devices, they are getting the different IP addresses over here. We can see for the second I have defined as the 2, 3 and 4. So you repeat the same procedures because I have done over here. So I will just remove these configuration whatever I have made just now. Okay. And now then after we will check whether we have configured the network properly or not. So just by simply sending the packet from these to these. Oh, okay. Acha. Just a sec. I need to check first. One. all the devices are configured or not. Acha. 10.0.0.2, and then the last one 4. Yes, we are done. Okay, now we will send a packet from this device to this, and you can see the status as a successful one. We can see the simulation. We go to the simulation, and you can see that the packet is moving from PC 0, then switch 0, then switch 1, then switch 3, then switch 4, then to the PC3, and then there is a acknowledgement. Right? Yes. Now, now, we can okay, we can check whether we have configured a network properly or not with the help of a ping command as well. I'll select the PC, and I want to check whether I have made the proper connection or there is a connectivity with the 10.0.0.4. So I'll open the command prompt, type ping 10.0.0.4, enter. So you can see that 4 packets were sent and all are received. No packet is lost. That means the configuration is done properly. So that was what is about the bus topology. Next is the star topology. So in a star topology, you can see over here there is only one switch and that is connected to different PCs via automatic connection, right? And we will be doing the same thing. We will be configuring the PCs. So you can see over here PC1 that is configured with address 0.1. Then this is configured with address 0.4. Okay, acha, here not mentioned 11.0.0.4. Then this is configured with the address 11.0.0.3, and this is, let us check, this is 11.0.0.2. Yes, we are done. And then let us check with the ping command. Let us send a packet from these 0.1 to 0.3. I'll select a PC. I'll go to the command prompt. I'll type ping 11.0.0.3. Enter. So yes, we have done it properly. You can see the ping command has been executed successfully. So that is what for the star topology. Then is the mesh topology. So you can see over here every node that is connected to every other node via a dedicated connection. Okay, that has formed a mesh topology. So what we have different devices. We have the end devices. Those are the PCs and the switches. Because now switch has multiple ports. So what I have used as a 24 port switch. So you can see over here. We'll go here and switch, and that's nothing but that 24 port switch that I have selected. And then after I have made the connection, every node should be connected to every other node by using automatic connection. This connection has to be used. And then after once the connection is done, you configure all the PCs. Okay. And once it is done, You can check the configuration by sending a packet from one end to the other end, or by checking with a ping command. So let us check. For this, it is 11.0.0.1. So 11.0.0.1, and let us check for this, it is 11.0.0.4. So yes, address is already been assigned. So let us check with the ping command from these PC to these PC. Okay. So I'm selecting these PC, and we will be going to the command prompt ping 11.0.0.4. Yes, the status it is showing that it is successfully configured. At the same time, let us check with by sending a packet from these to these PC. Yes, it is showing a successful transmission, right? So that is what is about the mesh topology. Then the another topology you can see over here is a ring topology. So the devices they are connected on, okay, that has form a ring type of connection. Okay, so the connection is done via these switches. The type of switch that I have used is a 24 port switch that was used for the mesh topology. And then the end devices PCs, and the connection between them is done with the automatic connection. And yes, similarly, whatever we have done for the previous topologies, assign IP address to each and every PC. Okay, and then after you check whether you have configured the network properly or not. So here I have used address 12.0.0.1. Let us check for these end device what address I have used, 4. So let us check whether this is configured properly or not. I'll use a ping command. Ping 12.0.0.4. Yes. So that is, you know, configured properly. Uh, that is a ring topology. And the another is similar to the ring topology. What we have is a dual ring topology. So basically, if the backbone line, there is a problem in a backbone line, uh, in this case the network does not fail basically when there is a double ring. The entire traffic that is transferred to the another line, that is a secondary line, whatever is there. So first we will check the existing network, and we will then break one of the line, and then we'll check whether there is a problem in the existing network after breaking the any of the line. So what we have a address here 12.0.0.1, and for this PC let us see what is the address we have, 12.0.0.4. Okay, uh, the connections are to be made similarly whatever we have done for the previous one. Only the additional thing is that here uh, two rings are there. Okay, dual ring is there. So let us see whether there is a communication from these to these. So 12.0.0.4. So I'll use the ping command 12.0.0.4. Yes, so that is done properly. Now let us remove any of the line. Okay, so we will remove any of the line, PC, not PC, these line. Okay, yes, that done. And now uh, let us check again whether by sending the ping command we are able to do the same thing. So the same message, same ping command, communication with the same PC. So yes, see, successful transmission. So even though there is a failure in a backbone link, because we have the another link, that's a secondary link. There is no failure in a network, and the traffic get communicate packets get communicated to the intended destination, right? So that is what is advantage of a dual ring over a single ring. Either here, what would have happened if there is a failure in these link, the entire network would have been collapsed, right? So that is what is a disadvantage with the ring topology having a single ring. But the practical networks, always remember those are based on the dual ring, wherein there is a backbone line always. And the last one is a hybrid one. So more than two types of topologies you can see over here. This one is a ring topology. Then the different nodes, those are connected to that particular ring that has formed the bus type of fashion. Then we have connected the mesh kind of network as well, and here a star network as well. So what kind of this network called as? It is called as a hybrid kind of topology. Okay, so let us send a packet from one end to the other end. What I have defined for these PC as 192.168.0.1. So now, because your packet will be moving from one network to the other network, okay, what we will be doing? We will be assigning IP address, and along with that a gateway. Okay, so what the gateway I have used? 192.168.0.100. Okay, same gateway should be there for that also. So let us check the connection between these two PCs. So I'm not going to configure all the PCs. I am just checking with these one. So I will assign a address other than whatever I have defined for this. यहाँ पे we have given as 0.1. Here let us give a 0.3. But the gateway is common, that is 192.168.0.100. Okay. And now let us send a packet from this end to this end, and see there is a successful transmission, right? So let us check with the ping command as well. Ping 192.168.0.3. So yes, uh, the data is sent, right? There is no loss of the packet. So that is what the hybrid topology as well, wherein there is a combination of different type of topologies that is also configured properly. So I hope you understood this session. What we have learned, we have revised the theoretical concepts related to all the types of topologies. What we have started with, the basic topology, that is a bus, then star, then mesh, then ring, dual ring, hybrid, right? And we have seen all the advantages and disadvantages associated with the with those topologies. So that was about the entire session of learning of topologies. Hope you people understood it well. Okay, bye.